Today I am going to do one more problem on the Bernoulli equation. Right? I read the problem. It is problem statement. A pipe through which water is flowing is having diameter 20 centimeter and 10 centimeter at cross section 1 and 2 respectively. The velocity of water at cross section 1 is 4 meters per second. Find velocity head and also discharge at section 192. We have to find velocity head and discharge at section 192. Right? What is given in the problem statement? Just concentrate here. He has given diameter at cross section 1 and diameter at the cross section 2. Diameter at cross section 1 is 20 centimeter. You divide it by 100, that we get 0.2 meter. Similarly, diameter at cross section 2 he has given, that is 10 centimeter, divided by 100, we get that as a 1 meter. And velocity at cross section 1 he has given, that is v1 is equal to 4 meters per second. Right? He is asking us to calculate. Right? He is asking us to calculate velocity head, that is v square by 2g, right, at 1 and 2. Right? At velocity head at 1 is v1 square by 2g, velocity head at 2 is v square by 2g. Also find discharge at 1 and 2, that is q1 and q2 we have to find. It is a pipe, right? It is a pipe through which the fluid is flowing. Cross section 1 I have shown, cross section 2 I have shown. Cross section 1 diameter is 0.2 meter. At cross section 1 velocity is 4 meters per second, and diameter at cross section 2 diameter has given 0.1 meter. v2 has not given, that we have to find. Right? Once if you find v2, we can calculate v square by 2g. v1 square by 2g we can find, because v1 value has given, that is velocity head we can at cross section 1 we can find easily now only. To find velocity head at cross section 2 we have to get value of v2. How to get value of v2? It is very simple. You know continuity equation. Here continuity equation is applicable, that is q1 is equal to q2. What is q1? q1 is equal to a1 v1, cross sectional area into velocity of fluid at section 1. Similarly, a1 v1 is equal to a2 v2. a1 is equal to pi by 4 d1 square. Right? I substitute d1 value, that is 0.2 whole square. Right? If I substitute the value of d1, I get a1 value. Similarly, right, v1 he has given, that is 4 meters per second. Similar way we can calculate the a2 value. You calculate a2 is equal to pi by 4 d2 square. So you substitute the value of d2. Once if you substitute the value of d2, we get the a2 value. So we have to find v2 now. How to find v2? Apply the continuity equation. You substitute all the values. a1 we know, v1 we know, a2 also we know. Right? So we can calculate the v2. v2 is equal to, from continuity equation, v2 is equal to a1 v1 by a2. You substitute all the values. You substitute the value of a1 v1 divided by a2 value. So we get the value of v2. v2 is equal to how much? You know, v2 is equal to 16 meters per second. Similarly, velocity head at cross section 1. Right? Now we can calculate velocity head at cross section 1, that is v1 square by 2g. v1 value already given. You substitute that value, we get velocity head at cross section 1, that is 0.815. velocity head at cross section 2 also we can find. Just now we got the value of v2, substitute the value of v2 in the equation, v2 square by 2g. Right? We get that head, velocity head at cross section 2, that is 83.047. Right? Rate of discharge we know, that is a1 v1 is equal to a2 v2. I take a1 v1, I substitute the value of a1 v1. If I substitute the value of a1 v1, I get discharge. Right? a1 is equal to 0.314, v1 is equal to 0.4 meters per second. Right? I got a1 v1 is equal to 0.1256, that is equal to a2 v2, that is discharge. Okay.